The quadratic formula provides a solution to a quadratic polynomial equation when it's equal to 0 for all quadratic polynomial equations, written in terms of just their coefficients. So if we consider the function f of x equal to ax squared plus bx plus c, we set this equal to 0, and we complete the square, we'll get a solution for x that'll represent solution for all quadratic polynomials equal to 0. Remember, for completing the square, we need a monic polynomial, so we must divide everything in the equation by the leading coefficient. This is what a monic polynomial is. It's a polynomial whose leading coefficient is 1. We end up with this equation. Now we need the constant coefficient out of the way, so we subtract it. And now we perform the step that completes the square. We take half the linear coefficient. Remember, taking half is just multiplying by a half. Square it. And the result, we add to both sides of this equation. This makes the quadratic side a perfect square, which factors to x plus b over 2a quantity squared. Notice what's under here is what's under here. Right? On the left side, we need these to be added together. They're fractions, so we have to make them have the same denominator. Once they have the same denominator, we add the numerators, keep the denominator. Now notice we have something squared on one side of the equation and a number on the other. We apply the square root property. It says we take the square root of both sides. Notice on the left side, the denominator is a perfect square. So we apply the square root to that, but the numerator is not. So we leave it under the radical and just carry it down. Now, on the right side, we have the definition of absolute value. The square root of something that can vary squared. So this gives us the absolute value of x plus b over 2a. And to solve absolute value equations, absolute value just means that what we have can be positive or negative. And it's bars, right? And remember, the equal means what's in my bars here is equal to this over here. So we put the plus and minus over here with this, and now we have exposed x, which remember we are solving for. So we subtract this to get x by itself. You can see these on the left side have the same denominator, so we can put them over that denominator. And notice we have a solution for x written in terms of the coefficients of the original polynomial, a, b, and c. This is what's called the quadratic formula. To use this formula, we make sure that the quadratic polynomial that we are given is equal to 0. So say we have 2x squared plus 3x equals negative 1. We need to ensure that it's equal to 0 so that we don't make a sign error. So the signs of the coefficients are given when it's equal to 0. And we identify the coefficients. A is the leading, that's the number multiplying the square. B is the linear, it's the number multiplying the linear term, notice the exponent of 1. C is the constant coefficient, it's one without the letter. We take the formula, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. This is something you should have memorized because it's used everywhere in mathematics, science. Now we plug in the pieces. Negative b, you just change the sign of what you found for b. If it's positive, you make it negative. If it's negative, you make it positive. And you take the square root of b squared minus 4 times a, which was 2, c, which is 1. And this is all over. Remember, this formula says we're dividing the entire numerator by 2 times a. So make sure you divide everything in the numerator by 2 times a. Now we simplify. 3 squared is 9. 4 times 2 times 1 is 8. 2 times 2 is 4. Nine minus 8 is 1. Square root of 1 is 1. Notice all of these are whole numbers, so we can split them up. That is, if you get a radical that can't be simplified, you can leave the answer in this form, but we didn't. We got a whole number under that square, from that square root. So remember, plus and minus are two things, so we must split these up and determine what the numbers are. Remember, most instructors want you to simplify or reduce the fraction to lowest terms. So these two are our solutions to the quadratic equation that we started with.